out of my sciatica today, and I was taking the dogs out for a walk, and it was a short walk, boy. As soon as they did their thing, they came back in. I had a my couch treats my sciatica really well. Usually, when I sleep wrong on it, it's when it really hurts. Um, but sitting on my couch really almost fixes my sciatica. However, my position of my pelvis to my nerves or whatever, it's magic. It's really kind of cool. No drugs, nothing. Just sit on the couch. Excuse me. Okay, so let's jump in here. And there was a chat. Who was that? Oh, Galena. They they will be graded soon, I promise. I know it's been sitting there. It's I've been anyway. I've had my challenges health-wise over the last week or so, and I've been trying to fit them in as best I can. Well, there is a rush. If I was you, I would be kind of going, what the hell is going on, Ferguson? Um, let's see. Today's lecture is Unit 4. It's going to be kind of a review. I'm just going over uh, last spring's test 4, but I'm only going over the OChem part. So today's lecture is going to be kind of short. Um, but I wanted you to get an idea of what I want you to study for next week. Now, next week is going to be uh, our next test. It's going to be in person, and it's going to be Thanksgiving week. So, you guys that have issues on Wednesday, somehow you need to talk. Either get in on Monday to take the test or something. Anyway, we need to work through those. Okay. Any other questions? All right. So let's zip over to this here. Okay, so this test covered the biochemistry part as well. So you needed to know the amino acid structures. So I have a form on the back here with parts of the amino acid missing, either the name or some part of the structure. And you needed to fix these. That's what question 1 is all about. Okay, name the following. Okay, so this is what? This is an amine. And there's 2 ways to name an amine. We can name it via the IUPAC. Let's name that first. So I have a stupid smoke alarm beeping if you hear that in the background. Okay, so we've got a 2 methyl groups here off this nitrogen. And then we have a the common name for this is going to be hard because we need to name this guy here. Let's do this differently. Let's name that instead. Okay, so we have, let's use the common name here. Okay, so we have 2 methyl groups and we have a 1, 2, 3, 4, 5, 6, 7. So it's going to be a dimethyl ethylamine. That would be the common name. The other name would be, okay, we have a backbone here. Let's now using the IUPAC way, here's the backbone. So it's a heptane derivative. And we have two methyl groups, so that's N, N, dimethyl, NN, dimethyl, 1 amino heptane. So amino group is not a functional group as far as naming goes. It's going to be a branch. That's why we're naming it right here as a branch off of heptane. Okay? Or you can name it as a common one, assuming I don't say name it two ways. Okay, so that's really important on this here. The amino group is treated as a branch, not a functional group. Functional group changes the name here. So we're naming this as an alkane with an amino branch. Does that make sense? Okay, here we have aniline. Which is the aromatic base structure. And we have two ethyl groups. So it's going to be N, N, diethyl aniline. Okay, as soon as we see the amide over here, we need to go back over here and look at this here. Now, this is basically an 8-carbon amide. Okay, so backbone of 8, and we have now we don't have an NN here. That means this is just going to be hydrogens over here on the nitrogen. So we've got three methyl, 1, 2, 3, 4, 5, 6 ethyl. Okay. So if there was anything hanging off of this nitrogen over here, we'd have to have the NN or N like we did up here. Or like this. Okay, so we have ammonium chloride. Okay, ammonium. Okay, ammonia is going to be a cation. And we've got NN ethyl methyl. Okay, 3-propyl-aniline. One, two, three. Notice there are hydrogens only on this nitrogen here. So there's no NN up here in the name. Okay, so we have an amide here. So we have a 5-carbon backbone. And on carbon number 2, there is a phenyl group. And on the nitrogen, we have 2 methyl groups. So again, this is the backbone. These would be secondary backbones over there. Okay, leucine, phenylalanine, those are 2 amino acids, and that is not going to be covered in this test. That is part of Unit 5 as far as our class is concerned. Okay, so we've got 3-amino-pentane. So backbone of 5. And we can start on either side of the pentane. Let's start on the left here. So it's 1, 2, 3. And there's no NN in that, so it's just plain hydrogens off of it. And 2 biological molecules that are amides. There's a zillion of these. One of them is going to be this is part of Unit 5, but any protein is going to have an amide. Those are called peptide bonds. So you can name a protein. You can name insulin as a polypeptide. Anyway, there's a lot of amides out there that are quite common. Okay. Label the following molecules with all the intermolecular forces that may be appropriate. Okay, so first of all, LDF for all, London dispersion forces. Okay, everything's got London dispersion forces. Okay, this is an amine, so it has hydrogen bonding. This has got hydrogen bonding as well. And okay, and then this would have dipole, 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 dipole. Okay, and N-octane would only have LDF, nothing else. Okay, rank the boiling points for the following. Okay, the stronger the IMF, the higher the boiling point. Okay, now let's list the intermolecular forces for these guys again. So LDF for all. So this is going to have H bonding and dipole, dipole. This is going to have dipole, dipole, H bonding, and dipole, dipole. Okay, so then how do you characterize then the difference between, well, first of all, this is the lowest out of 1, 2, 3, 4, 5. Let's say 5 is highest, so this is going to be 1. And the reason is LDF only. Okay, number 2 is going to be the aldehyde. And that's got dipole, dipole, no hydrogen bonding. So we have 3 of these molecules that have hydrogen bonding and dipole, dipole. Okay, so the acid is the strongest. So that's going to be a number 5. And then we have a nitrogen bonding to a hydrogen, and we have a oxygen bonding to a hydrogen. So this is stronger, so that's going to be number 3. And it's got hydrogen bonding to oxygen. This is number 1. Number 2 is this guy. This 3 and 4. Okay, 4's got hydrogen bonding to oxygen, which is stronger than hydrogen bonding to nitrogen. And then 5 is we have hydrogen bonding to oxygen plus dipole, dipole dimer. Remember, a dimer with carbonic acids is when 2 acids hook up together. Okay, so we have draw the structures. Okay, let's draw the structures really fast. Hexylamine. So that means you're going to have a nitrogen. Oops, a nitrogen on times. And we have hydrogen, hydrogen, and then we have a 6-carbon attachment there. So 1, 2, 3, 4, 5, 6. And then we have hexanol. Okay, so most soluble. Okay, that means strongest intermolecular forces. Okay, so these both have hydrogen bonding. But this bonds to nitrogen, this hydrogen bonding bonds to oxygen. Stronger, because oxygen is more electronegative than nitrogen. It's closer to fluorine. Okay, so that means this is more soluble. And why is it has stronger intermolecular forces, because hydrogen bonding is stronger than hydrogen bonding over here. And they both have dipole, dipole, and LDS. But this is the part that's making the difference. And then you can do the opposite. What is the least soluble in water? That would be then the nitrogen one, because the hydrogen bonding is with nitrogen is weaker than hydrogen bonding with oxygen. Pearl. It's okay. Okay. So we have two molecules. We have trimethylamine. And then we have acetic acid. Okay, so at pH 11, greater than 7, there will be no visible reaction. At pH greater than 7, what's going to happen is the OH is going to grab hold of that proton. So we're going to end up with that. And then to continue this, we had it's okay. Okay, so we had this at pH less than 7. What would happen? The proton would then do a coordinate covalent bond to that electron pair. So we'd end up with and then the mechanic would be no visible reaction because the proton is not going to do anything. It's going to keep the, if anything, it'll make sure it's protonated even more. Okay, so you're definitely going to have some of these guys. All right, so let's look at some reactions now. Okay, so what happens to an amine in water? This is like if we have ammonia, NH3, and water, what do you end up with? We end up with ammonium hydroxide. So what happens is H from the water goes here, gives you N. So whenever we throw an amine in water, it ends up uh, reacting with the water, forming OH groups, which makes it an alkaline or basic solution. Which is why ammonia products are always good around grease, because what happens is the alkaline environment around grease saponifies the grease into soap. Okay, so here we have an ethylene chloride. Now we have to name these. So this is going to be ethyl methylamine. This would be ethyl methyl. Okay, so this is the acid chloride. Okay, so what's going to happen is we're going to end up with an amide. So this is going to be the so this is going to be N ethyl methyl nilamide. And this is going to be um, acid chloride, and this will be ethyl-methylamine. Okay, so there's three ways to make an ester, three ways to make an amide, but one of them is totally too slow to even consider as a reaction. So really, there's only pearls. So really, there's only two ways to make an amide, and that's using the anhydride or the acid chloride. Okay, so if we look at this, so this is the acid part. This is the amine part. So we need a 1, 2, 3, 4 carbon backbone for the acid with a methyl branch at position 1, 2, 3. And then we have a NN dimethylamine. So the acid chloride is going to be that. And then the anhydride is going to be, remember, it's anhydrides are dual esters. So it's going to be like this. And the amine, which is going to be dimethylamine. Okay, proteins conformation, that's for unit 5. Enzyme moderator, unit 5. Talking about amino acids specifically, they're very special molecules, and that's a unit 5. And talking about enzyme, that's unit 5. Here's a protein with cross-links. I'm going to talk extensively about the kinds of cross-links and how strong they are. For example, this is the weakest, that's the strongest, and why. And here are our amino acid table to fill out. Okay, so basically it's going to be, your test next week is going to be basically what we went over today. With probably a few more problems in terms of reactions and possibly naming, just so that the length is reasonable. Okay. And then if there's any issues with schedules next week regarding vacations, being away or whatever, we need to work through those. Okay? Are there any questions about the test? And then we'll have, when we get back from, vacation, we're gonna be doing the enzyme lab, and that'll be the last lab. And then from then on, we're doing, projects. Okay. What would you guys think of that?
Need to go study.
Yes. Well, it's less to study though, and then it could be. I could have thrown in the protein part, which adds some complexity. So the bio.
Thank you for not doing that. Thank you. I'm sure we all appreciate it.
Thanks for saying that. I just would like you guys have a nice holiday. I don't know how your other classes are, but I attempt to make life easier around the holidays. Okay, so
So we will have class on Monday, just not the rest of the week. Is that correct? Next week?
yes, we'll have another review on Monday. Yeah,
One more review. Are we having lab class or is it just lecture?
just lecture. The lab is going to be the test
Okay, and we're coming in for that or is it online?
coming in person.
Okay, then I'll see you tonight and next Monday. All righty, thank you.
All right, no more questions. I'm going to end this, and I will see Monday, folks.